cloud. I will be so happy when we don't have to deal with Zoom anymore. I actually have to deal with it in the summer for my summer course, but I think that's it. All right, so for those of you just joining us on the second slide or so, we're just talking about gap analysis in the context of migration, migrating applications, migrating platforms, databases, whatever it happens to be. The first step in a gap analysis is getting a stick in the ground about like, where are we right now? And I'm just, mentioning how difficult it is sometimes for companies to get up their arms around, like, what do they have? And part of the problem is this idea of stovepiped apps. When I talk about, whoa, yeah, that was sweet. When I talk about stovepiping, it's just this. So most companies are organized in, divisions or, at least large groups, and each division's got a VP sitting on top of it. So this might be marketing. Okay, yeah, this is working well. Yeah, it's marketing. It's a T. Here's sales over here, sales. Here's engineering, and so on. So each group within the company has their own VP. The budget in that kind of company flows from the top down to the VPs. So it's the VPs and senior VPs who are really advocating for budget for, the quarter or year, whatever their budget cycle looks like. So they get this bucket of money that they've got to spend over that period of time. In stovepipe organizations and Blue Cross Blue Shield, Massachusetts, where I did some consulting, at least at the time, it's been a decade since I've been there, so they may have progressed. We were trying to shove them in a progressive direction, but like they were the poster child for this. Every division had a senior VP in charge. They all had budget. They all did their own projects within that vertical space. So marketing did marketing projects, sales did sales projects, engineering did engineering projects, and so like they were all really different. And the decisions, technical decisions they were making, were not connected to each other at all. So marketing might decide on an Oracle solution, an Oracle BI sort of thing with God knows, what platform they're sitting on. Engineering, in the meantime, they might decide on a solution that involves, you know, MongoDB and Node and so on, like really different technologies. And especially at the data layer, what we found when we went into companies like this was that there just wasn't any coherent way to move data across the enterprise. And like that's the lifeblood of any company. Like data is blood, for these folks. And if you can't move the data around, the company's going to wither and die. And there's some exceptions. Like I was never in the manufacturing space, so I'm sure there are some differences there. But at least in the financial services healthcare space that I played in, this is what it looked like a lot of the time. It costs a lot of money to set up your company like this. Like when we did the analysis for Blue, we identified all sorts of savings over several years for getting rid of this sort of stovepiped approach and putting a consistent layer on top for data, especially data. I look like I can do cursive. Can you believe they're not teaching cursive anymore? So silly. So what our approach was to, at least at the data layer, put a consistent platform across the top of all these organizations with an interface that they could use to move data from one spot to another. It was a challenge. I mean, one of the challenges for that kind of project is this stuff up here, like who's going to pay for it? It's not coming out of any individual VP's budget for sure. They're not going to pay for something like this for the entire company. Getting all the VPs together to agree, on like a tax or something to pay for this sort of infrastructure, yeah, good luck with that, because they want every penny that they can spend, because in this sort of company, spending money is power. And so these sorts of projects usually came out of the C-level. Like when I worked on this at Blue, that was out of the CTO's office. He, at least, Rick, I think was his name. Like, Rick like understood like they were wasting just so much money because they didn't have a consistent data strategy. And we did some work helping them with that. They also had some massive QA issues. They basically just didn't have QA, and we helped them set up some QA groups and a quality assurance office to run all of that. But anyway, like that's what I mean by stovepiped. It's mainly budgets being spent vertically within each division without a lot of communication between the divisions. So you end up with all these really weird disparate apps that can't really move and move data or talk to each other simply. It's typically a bad thing. Clear those drawings. And so we're doing this, oops, clear it again, huh? Clear my drawings, get rid of that. So we're talking about, the first step, which is like, what do you have? Sometimes it's literally just going desk to desk and asking people what they use day to day, or going down to the data center and talking to the operators like, hey, so like what's in these racks? Like, what do you have on the racks in terms of data or application servers? Like, what are they? Sometimes you get lucky and there are tools we can use. So for networks, for example, if I need to know all of the workstations sitting on a network, there are tools that I can run internally that'll go out and probe the network and get information about, oh, this particular machine is running this operating system, this version, here's this IP address and so on. So I can do sort of a topology kind of thing automatically. And databases, there's a lot of tools around data, so I can dump ERDs, entity relationship diagrams, so I can see what the databases look like, at least from a table standpoint and their keys and so on. But this first step is just a serious documentation effort around where they are right now. You should be able to go through that document and get a really clear picture of all the applications running and what they do and how they interact. And then the next step is the future state. This is the fun part, I think. The future state is, where do you want to be? And it might be, where do you want to be in a quarter, 3 quarters, a year, 2 years, 5 years? This is just from where we are, like what's the ideal environment that we see in, let's say, a year? Like, if you've got a good future state and you understand the past as well, like what you've got, that makes life really, really easy. The problem with the future state is that people, especially the business side, they don't know what they don't know what they don't know, and they don't know what's possible and not possible, which I guess is like why we have jobs, right? That's, as technologists, like that's our job to understand what we can and can't do, or at least how hard something's going to be. Yeah, I guess I made a lot of money doing that, I suppose. So I guess being a technologist in that case was a good thing. But it's really important to get as detailed as possible vision of where they want to be. Maybe it's additional functionality. Maybe it's just we need to refresh the platform because we're on an old system, like an old Solaris machine or a set of servers, and I need to move to something more modern. So it could be just anything. But this involves, it's almost like requirements gathering. I've got to go and talk to the business and really get a pretty clear vision of where they want to go. And once you got those two places, like once you get done, there's a huge question. Hang on. You've also system migrations, also referred to database migrations, new requirements, new DB design. Yeah, actually, Yuval, absolutely. And we'll talk a little bit about data migrations toward the end of this lecture. It's just any change, really. Anytime you're making change, even if it's just minor, like this is kind of standard procedure for implementing change. I got to know where I am. So I don't know where I am, I don't know what I need to do to get to that future state. And that's actually the gap. So the gap is, I've got those 2 points. Now let's figure out, how do I get from where I'm at to where I want to be? It's almost like taking a trip, It's like part of the trip is that, okay, I'm here at home in the middle of COVID, climbing the walls because it's making me crazy. Where do I want to be? Oh man, I just want to sit in a cafe in Paris and sip a cafe creme and have a baguette or something. That's my future state. Well, then the planning occurs. Well, how do I get to that cafe? Oh, I've got to book a flight. I got to book, someplace to stay. I got to make sure my passport's up to date, all that stuff. Like, those are all the steps that I need to take to get to that future state that I want to be in. Again, we need to be pretty detailed. And I guess it depends on the level of effort for this sort of work. Like some companies just want, oh my God, who is famous for this? TJX Corp. TJX is those are the guys who run Marshalls and TJ Maxx, and there's one other A Wright or somebody. Those guys, right? So they're in the retail, low end retail, sort of seconds almost market. Their margins are just razor thin. TJX would always call us up for this sort of migration work at my consulting firm and say, "Hey, can you come and help us with this?" And we'd say, "Sure, of course." So we'd go out and spend 3 or 4 days with just getting the feel, like what do they need, where are they at, that sort of thing. And then, maybe we'd start that on a Tuesday. And then on a Friday, we'd sit down with them and lay out, like, here's what we see. Here's the broad steps that we think need to happen, and just a real ballpark, like order of magnitude estimate on how much all this might cost and how much time it might take. And they would, this is all free, right? Because we're going to bid the business, so we want to get in there and like get information for the bid. TJX here in Boston. No, they're out in Framingham. TJX is in Framingham, or at least their corporate offices. They might have satellite offices out here. But end of the day, end of the week, we haul our ass down to Framingham and sit in those boardrooms and talk with these guys about the project, and they'd say, "Oh, thanks very much. Like, we really appreciate the effort. We need to call." And we knew they weren't going to call. They knew they weren't going to call. It was all about, they just wanted some advice. Like, they wanted a ballpark estimate for some work they had coming up to see if they could afford to budget it and so on. There was no intention to hire us for the work, and we knew that. It really was about relationship building for us, and which was great because it got to the point where we'd done so many of them that any of us on the senior team could just walk into, like, a CIO's office or CTO or senior VPs and just sit down and have a chat with them about whatever they were working on. If I happened to be driving by Framingham, I just stop in and say hi for relationships. Same thing happened at DET here in Massachusetts. DET is the Department of Employment Training. Might be the Department of Employment and Training. Anyway, it's the unemployment office. They've got a fancy name. And the guy who ran that was really into old computers, like, stuff you'd find at the MIT Flea. And I was constantly dropping in to talk to him because he'd always have some really interesting machine sitting in his office, and we'd spend an hour, like, he'd go like, "Oh my God, look at this. I got this, this Vax pizza box, and I don't know anything about them." And I was like, "Oh, hey, I used to work on these. Let's see if we can get it running." And we'd play for an hour, just trying to get it booted and so on. And then I'd just leave, like, not even talking about work. It was a great job. That and the golfing was fun. I suck at golfing, but it was fun to go golfing. So that's the gap. Like, we're doing this gap analysis, right? We're trying to figure out how to get to where they want to go. It's the road trip. It's the plan to get there. This often ends up being documented in something called a statement of work. So if you do the plan in a really detailed fashion, like, that can be used as the blueprint for the project. And so like TJX, if they had said, "Oh, like, this sounds really good, can you put together a SAL for us?" Like, we would have gone an extra step, probably spent another couple of weeks out there doing the real analysis, lay everything out. And this is a requirements document. So it's going to have goals, non-goals, who's in charge, all of that stuff. It's going to be a full sort of project plan at a high level. And then that statement of work, A, becomes the migration plan for the project, and B becomes the contract to start things going. Start them going. So that statement of work is really, really important. And often that statement of work, the first one will go out for, let's say, 2 weeks. The first statement of work is the gap analysis, and then the second statement of work is the ongoing work that you're going to bid. As a consultant third party, you're going to bid that project and hope you get the project. And typically, if you're the team doing the statement of work, like doing the gap analysis, like, more about it than anybody else, so you're probably going to get that work. All righty. So that's the gap and the gap analysis. It's essentially, here's where we go, here's where we're going, here's how we're going to get there. Once we know that, and honestly, like, as we're doing this, like, we're getting a feel for what the project is going to be, there's a couple of approaches we can take. And I sort of break them down into this sort of alliterative, rhyming sort of thing: adapt, scrap, or wrap. And which one we do depends on a lot of stuff. So we're going to look at all three of these, of course. So the questions that we're going to ask, though, that are going to lead us to these approaches, and this we'd be doing during the gap analysis. So things like, that second bullet, will the existing system be supported in the future? That really informs us as to how much work we're going to do. If I'm doing an extension to an application, but I know that the whole platform is going to go away in, say, a year or 2 years, I'm going to approach that really differently than if it's like a greenfield thing that I'm building a new system that's going to be supported for quite some time. So two things. One is I don't want to put a lot of effort into the platform itself because it's not going to be supported, which means that I've got to design systems in such a way that they're going to be portable, because I know the existing system is going to go away. There's going to be more layers probably because of that. I've got to have something that will adapt quickly to a new system, and that's actually going to be a second project, right? The second project would be, oh, now the system's unsupported, and now we've got to move to something completely new. Is there sunk cost already? Could I explain what three steps? These 3 steps? Oh, these 3 things? Adapt, scrap, and wrap? James? Oh, yeah, that's the rest of the lecture. So stick around. I know everyone gets really excited, when I lecture. It's like, oh, tell me more. And it's like, oh, just calm down. Oh, we'll get there. Sunk cost. A lot of companies are really price sensitive, and a sunk cost means it's money I've already spent and I'm not going to get it back. So that's, purchase cost, lease cost, maintenance costs that I've done, upgrades and so on, facilities, money I'm never going to get back. If I've got a lot of sunk cost already, I'm going to be hesitant to get rid of what I've got because I've paid a lot of money into it already. Why would I, it's like a car. A $50,000 car, and over the years I've put a couple $100,000 into it. Like, I'm probably not going to sell it at the end, right? I'm going to keep it because I've got all this money, and I'm certainly not going to get that money back. It was just for my own pleasure. So sunk cost is an important question too. A lot of companies don't know how much it's cost. Like, that's not something they think about a lot. I mean, the finance guys do for sure. So you got to go talk to them. But like, that's not something that's forefront of mind typically. That last bullet, this is one that was really important to me. Is there an opportunity to leverage this work somewhere else? And very often that's how we would pay for stuff. Like Blue, that sort of siloed approach that I mentioned that they had, with each division spending their own money just kind of on their own. That top piece that was going to unify the data across the entire enterprise, like, no one wanted to pay for that. The way we paid for that was, look, over, let's say, 3 years, you'll say you spend $1 million on the project. Over 3 years, we're projecting like a cost savings of $2 million just in reduced effort of moving data around. Well, there's going to be less friction between applications, more efficiency essentially. So the efficiency turns into money. Like, efficiency is time, and time is money. So we could demonstrate that, hey, you're going to spend $1 million now, but after 5 years, let's say, you're going to recoup an additional $1 million, over time. That kind of money can be used. I mean, most companies, you're just moving numbers around, right? Like, that sort of money can be used as budget. So I could spend $1 million, assuming that it's going to pay for itself in a certain amount of time. It's sort of like Biden's infrastructure plan. Like, right now, it's like, it's what is it, $3 trillion or something over 15 years or 10 years, and they're going to pay for it in 8 years. Like, this is the sort of thing they're working on. It's like, where is our end state? How are we going to pay for it? How are we going to get there, and so on. So these are interesting questions that we have. That this bullet, is the end state really the end? That's almost, the answer to that is almost always no. Most systems just grow and evolve over time. But if somebody told me, yeah, like this is the last release for this product, we're not going forward with it after that, but we need to do this one additional thing, maybe for compliance reasons or something, like I'm going to approach that really differently too. I'm not going to spend a lot of time on trying to make the system adaptable and, you know, extendable and so on. It's like, no, thing's going to die. I just got to patch it up and then we'll put a stake in it at the end. So all of these questions though, like these are going to inform us as to which approach we're going to take. And you probably will, you know, as you think about answers to these sorts of questions, you'll probably see which path they lead you down in the end. So let's talk about adapting first. If the gap is really small, so this is the gap analysis here, where we are, where we're going. If that gap is pretty small, I might be able to just adapt what I already have, assuming that the stuff I've got in place will support the new work. This is like an incremental upgrade. It's, frankly, it is like one of the biggest buckets of work that we do out in industry. It's like we're always just incrementally improving stuff. Oh, I add a feature, or I improve efficiency, I, you know, support logging, you know, whatever it happens to be. Like I'm just going to keep adapting what I have, maybe every quarter, every couple of quarters as markets change. The upside is I preserve sunk cost. So if I've got a lot of sunk cost in the system already, adapting it is not going to jeopardize that. It's small work, so I can do this stuff in small chunks usually. I'm usually not going to adapt something that's got a really, really big gap. So I can identify like 4 or 5 things I want to do and maybe spin them up as 4 or 5 projects, each of them small. And if I'm doing them in something like, you know, an agile process where I'm doing tight spins and then spitting out useful work, that was, excuse me, what was that? I can't remember what the name of that process was, but similar to RUP or even agile to some extent. That sort of work is really appealing because it's kind of like a smorgasbord, right? Or a buffet. Like a, you know, a CTO can go in and say, oh yeah, like let's do this quarter, and next quarter we'll do these 2, and then the following quarter we'll do that one. It's easy to budget because they're small. It's easy to get approval because they're small. The downside is, as I keep adapting these things, I get a lot of accretion factor. Stuff is just going to accrete onto this application or this platform. And it might come to the point where I've got so much stuff like bolted on, I've extended it so much that it becomes unsupportable. I never actually ran into one of those, but I could see it happening. I'm sure it happens all the time. So it's low risk. The downside though is that you're probably going to use what you've got for quite some time. And like the more I adapt it, right, the longer I use it, the more sunk cost I've got into that system. And so I'm going to be more and more averse to changing it wholesale as time goes on. Scope creep I mentioned down here because in this kind of small project that's really focused, scope creep comes into play big time. And scope creep just means here are the 4 things that we're going to do. I'm going to do this, 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 and this. And then somebody from the business says, hey, while you're in there, could you do this? Like, oh, you're working on the homepage, I see. You know, we always wanted a calendar widget on the homepage. Could, like, while you're in there, could you add that calendar widget for us? It seems like a small thing, right? It's like, oh, I'm already in the code. Calendar widget's probably a package I'm going to download from somewhere and just drop into that page. Like the work itself is probably pretty minimal. But the business doesn't understand that if I add something to the project, I've got to document it all. I've got to plan it out. I have to write additional tests for QA because that's something they weren't expecting. So I'm going to have unit tests on that. I'm going to have to have system tests, system level tests on it. It might jeopardize or change something else in the future. Like just dropping something into a page because you're there usually has ripple effects that is going to be more significant than the business realizes. So just be aware of scope creep. And especially as an individual contributor, as a software engineer at a company, you're going to be asked all the time, hey, could you do this? Could you add this? Could you change that? There's no hard and fast rule. Like, I'd love to say to you, like, never do that. Always go to your manager and ask. Like, it's gray area, right? Like, sometimes it doesn't matter. Hey, could you move this sentence down on the page? Like, yeah, sure, I can do that. It'll take me 10 minutes. Hey, can you drop this calendar widget on? Like that. Now we're talking a little more effort. We're gonna have to have budget for that. People are always trying to get free stuff out of you, including working more than 40 hours a week if that's what you're contracted for. Don't work more than you're paid for. So again, like this sort of thing, because they're easy, they're short, I can interleave them into other projects. At the end of the year or the end of the budget cycle, I might see going into Q4, like, hey, it looks like I've got a little extra budget. Here are these 2 things that have been hanging on my hook for a while. Let's go and do these adaptations, these little upgrades. So it's an easy way to spend money, I guess. And you never end up at the end of the year with extra money. Like, you spend every dime you've got, because that's just the way it is. It's the old use it or lose it mentality. So at some point, though, like, I mean, you can do this to a point, right? Like, you can adapt and add little stuff, and the application gets a little more complicated. I'm watching sunk cost and so on. At some point, though, you're going to get to the place where you just can't do it anymore. And the big decision has to happen, which is scrapping it. Scrapping is, it's a massive decision. This is a decision to take what you've got and just throw it out the door and start all over. I've done 2 of these. I think I've done 2 of these. One of them ended up being a multi-year project that I was the architect on. We love these as technologists. A scrap job is like, that is what we live for, because like sometimes we call these greenfield. Greenfield means that I walk out my door and there's this beautiful green field in front of me, and I can plant whatever I want. Like, I can landscape it, I can put a house there, like whatever I want to do. It's just a big open field with nothing in it yet, and I'm going to fill that field up. That's a really, really fun thing to do. Like, no craft, yeah. I love that stuff. It can be a challenge, though, because just the psychological hurdle of getting to scrapping is difficult for management. It's a lot of money typically. Like the big scrap we did, I can't remember if it was for Pioneer or Wellington or one of the big banks. It was down on Summer Street. It's been too long ago now. I think it was Pioneer. Oh no, it was Wellington. It was Wellington, down on Summer Street, 100 Summer. Like, their issue was, it was that end of life thing where they had, their core business was run off of HP mainframes, HP 3000s maybe. I think, was it a 3000? Anyway, they had a couple of HP mainframes in their data center. They had one guy who knew how to run the system. He had been there from the start and had built a lot of pieces of it. And he literally was the only person who knew how this stuff worked. Like, none of us on my team had any idea how mainframes operated. I mean, of course we knew about mainframes, but like running this system on that HP mainframes, like, who knows? And so we always had to go and ask Ken. Ken was this guy's name, Kenny. And man, oh my God, I remember Kenny. Kenny looked, I can't even describe him. He was all disheveled and scraggly hair, and he wore like nasty clothes. He smelled like he was one of those people. But if you needed to know something about the system, you go up to Ken's office and say, "Hey, Kenny, do you know how to run like this report? But we need this extra piece on it." And he'd go, "Yeah, sure, no problem. Come with me." We get out of the data center, and he'd start hitting the function keys on the keyboard. And sure enough, that would spit this report for us. Like, he knew all the key sequences for all of this. So he was the subject matter expert. And one day, so I got to preface it by telling you, Kenny, for breakfast, would come in every day. And for breakfast, it was Slim Jims and Mountain Dew at his desk. And then just during the day, he'd be pounding these things down. He loved Mountain Dews. So one day we come in, it's like a Monday, and there's no Ken. Like, oh shit, like Kenny's had a heart attack or something, and like he was the only guy who knew how any of this work. We're screwed. And so we're like, what happened to Ken? And it turned out, like, who knew? He was part of some community theater group, and over the weekend had been hanging sets on stage and fell off a ladder, and he'd broken his leg, and so he didn't come in on Monday. He came in a couple of days later, but we were just panicking that Kenny was going to drop dead at any given point. Knock wood, knock melamine. But anyway, so that was a scrap operation for us. And it was really fun because you literally get just a blank whiteboard and you start out. It's like, all right, here's the core business. Here's what it needs to do. Here's what it does now. Here's what they want it to do. And just start laying out in architecture. Really, really fun. G Fuel, the gamer diet. That was back before games were popular too. So I don't know what he was doing. So scrapping, I can usually, if I'm adapting something, I can get away with not doing the deep dive on the current state because, really I'm just adapting it, just changing one little thing. With the greenfield design, if I'm scrapping everything, I'm going to replace it. I have to replace exactly what was there. That's really tough. Like I have to literally understand every single thing that the existing system does, even if it is not used very often. It's got to exist in the new system. So the documentation on a scrap job is pretty high, pretty high. And even if I need to test it, I've got to test them in parallel or find some other way to duplicate what the old system was going to do. Like we used to just run two systems in parallel, the old system and the new system. You'd feed both the same data. This is financial services, right? So it's all financial data. So you'd feed each of the two systems data in parallel and then compare the results. And at the end of the day, they should be identical, or the new system should have enhanced features, that sort of thing. I mean, another way is try to duplicate like a production environment on the old system and move that data over to the new system to do testing. That's a tough road to hoe, man, because a lot of industries won't allow you to just pluck production data and use it to do testing because it's got identifiable information in it, so it's got to be scrubbed, and scrubbing almost never works. So usually we get a business analyst involved. The BA would help us develop the data sets to use for testing for old stuff and new stuff as well. Like they understood what the data should be going in and out, and they can help us set that up. And by the way, I'm sure I've mentioned it a couple times already, but that business analyst role, that's a really, really fun role. If you love technology, but you love technology, but you don't enjoy like getting down in the weeds coding, for example. And I was kind of like that, in my career. I was more of a high level kind of big picture sort of guy. But if that's you, and you also enjoy the business side of stuff, like you understand the domain, so that business analyst role straddles both. This is a person who is well versed in the technology, like they understand the implications of the technology, but they also understand the business domain. So they can talk to the business users, figure out what it is they really need, and then translate that into technical specifications that the dev team can use to build the application. And then also, it's basically they bridge that gap between the business and the technology team. It's a really, really cool role. And it's actually an interesting role as like an entry level position for someone in an industry. Like if you wanted to learn finance, go in as a junior BA at a place like Fidelity or State Street or something. You'll learn both sides of that industry. You'll learn the business side of the industry and you'll learn the tech stuff that they use. I think that positions you really well for your next job because you've got domain experience and you've got technical chops as well. That's a really powerful combination, I think. When I look back at my career, I can see that I might have gone down that BA path. I ended up doing architecture work, but the role was pretty similar to a BA, at some level. So a couple of words about testing. The thing about testing is most people do upstream testing. So well, I guess depends on where you're standing, right? Basically, I've got 3 boxes. I'll just draw them because I can. Let's see. Let's draw. Oh, I can draw a box. Hang on. Here's box. Here's box. Look at these boxes. Box, box, box. And then can I draw like an arrow or something? Sweet. So here's the new thing. This is the new guy here. And then what I've got is upstream systems that are going to feed this guy. And I've got downstream systems that consume data that the new system produces. So most of the time, we'll test one or the other. Like it's really common to test the downstream system or the upstream system rather. It's like, oh, I'm feeding data in from this into this new box that I'm designing. So I need to test to make sure that, I'm replacing something old. I need to make sure the new system does exactly what the old system did with that data. But then I also have to worry about downstream stuff too, because there's going to be systems that consume whatever this new process is producing. It's almost never the case that an application just sits standalone. It's always part of a larger system. So I've got to test both sides. And what I really need to test is end-to-end business process. Many companies don't do this. I actually wrote a paper several years ago when I was running a research team, enterprise research team, about that. Like you need to, if you're an e-commerce company, for example, the real testing is from the spot somebody places an order with you until something is on a truck for delivery. That's your business process. And you got to test these new components in the context of the end-to-end business rule. Like, does it fit? Like, there's a lot of stuff that, we always just draw single arrows, right, between systems. That's almost never the case. Like this new box, probably feeds, like if it's an ordering system, it feeds, sales probably gets reports out of that. Compliance gets reports. Finance gets reports. Manufacturing has to do some stuff. There's a shipping piece of that. There's a lot of subcomponents around this. It's like that systems view we looked at in UML, where I'm identifying all the players in this big process and where I sit, and then what are the interfaces from where I sit out to other things. What am I consuming? What am I producing? It's feeds and speeds, I guess. So testing is tough. Most companies don't do enough testing. Why? Well, it's obvious why. Testing is expensive, and a lot of companies don't see a need for it. It's like, oh, are you telling me my developers aren't producing good quality code? It's like, why should I spend 3 months testing this product? You just spent 6 months writing it. You tell me it's not good? But most companies, who understand quality will spend the money on QA and produce quality stuff. Like at Fidelity, the rule of thumb was 30%. So if we budgeted $1 million for a project, $300,000 of that budget was for QA at the end, or not even at the end, ongoing. They were serious about QA. I assume they still are. All right, so that's upstream and downstream testing. You got to do both. And again, the challenge is getting data, especially depending on the industry. You might have, requirements around what you can do with that data. Let's talk about wrapping. I got to do my, get rid of these things. Annotate, clear all my drawings. So this is the third approach. So we looked at adapt was the first one. We're just going to bolt stuff on, adapt what we have. And that's more opening code and changing code, just extending the code a little bit. Scrapping is throwing it all out, building a brand new system in its place. This wrap idea, it's kind of similar to adapting, except I'm not going to change the existing system. So in adapting, I go in and, I'm actually changing some code in there, adding new functionality or whatever. In a wrap situation, I leave the existing system in place and then put a layer on top of that that gives me the new functionality. It's pretty popular because I preserve sunk cost because I'm not touching the old system. A lot of times I don't know what the old system does. Like I kind of know how it works. It works great right now, but I'm not quite sure like what its capabilities are. And so this allows me to avoid even thinking about that. As long as I know what the interfaces look like, I can get in and out of it. Trying to think of a really cool example. Oh, this is kind of a wild example. It just popped in my head. So I worked on a system, actually had a application for this system, and unfortunately the company folded just before the patent lawyers got paid. So we developed video conferencing servers, big, like these are big $25,000 servers that enterprises would buy, companies. And I worked on a way to take seats from those video conferencing servers like across the internet and pool those seats together to create on the fly video conferencing rooms with, I can't recall the number, I think it was up to 16 participants at the time. And I remember we were on really, really slow networks back at this point in time. But I didn't, it was a wrap sort of thing. I didn't touch the existing video conferencing servers. Instead, what I did was I found that they had a telnet interface, and I used telnet to pass commands back and forth to these servers from my part of the system. So I essentially wrapped it with a telnet kind of text-based command interface sitting on top of it, and all of my stuff was outside of the video conferencing server. Essentially, we invented Zoom, uh, 15 years before Zoom would have been possible, even because of networks and just the limits of computing at the time. So that's sort of a wrap. I'm going to leave something in place and just put things on top of it. Maybe I've got a mainframe and it's really good at doing banking operations, like generating reports and doing batch jobs and so on. But now we want a web interface into that. Like, how am I going to do that? Well, if it's a mainframe, it's probably got key sequences that it responds to. And so same idea, I can put a layer on top of the mainframe that accepts these key sequences, or generates them rather, based on something that somebody does on the web. So I hit this page and I want to see my accounts. Well, this layer would generate the proper key sequences to get the account information and then translate it into JSON or HTML or something to display on the web. But the mainframe doesn't go away. So that's again, it's a really, really popular approach. And it makes sense, right? It's like, hey, I can probably, get a couple of more years or decade of life out of this system if I just stack some stuff on top of it. In fact, that's exactly what we're talking about. So wrap. Yuval asks, is there an argument that keeping the old system in place increases technical debt in the long run? Because now I got an old and new system. Yeah, absolutely. And I mean, I guess the old systems, usually they hit a state of equilibrium in terms of maintenance and backlog of stuff we need to do. I guess that just all depends. Like, somebody's got to make that decision, right, Yuval? And that's kind of almost a finance decision, I think, as to whether to greenlight the project or not. Or we could just hope for the best, right? And say, oh, yeah, it's going to run forever. What was my answer to this? I was going to wrap it. Do I have a picture? No, of course, no pictures. So nice wrap examples. Oh shit, I had another wrap example in my head too. I was going to talk about that. What was it? What was it? I can't recall. It was video conferencing. And what was the other thing we were going to do? Gone. Who knows? That brain cell died. Really see it jumping out of my head. All right, so wrapping is like, that's a pretty powerful thing to do. The solution, of course, I'm going to wrap this, and the second layer is going to be an abstraction layer. And actually, that's an interesting point too. Like, in any of these, remember that one of the first questions I was asking was, can I leverage this against something? Well, this reminds me of a project that I worked on. It actually wasn't a wrap in this case. It was, I guess it was kind of a wrap. We were taking an existing system to display news and stock quotes. that was custom. It was all written in Perl, and they wanted to extend it a little bit. They wanted, oh, so I've got all these, basically the news and stock quotes were coming from the markets, from the NYSE and NASDAQ and so on across a pub sub kind of architecture. And they wanted to add some feature to it. It's like, oh, we want, I don't know, futures or bonds or something. Who knows what the news was. But then the question was, all right, so that sounds like a wrap. And is the real question was, can I extend it? Can I leverage this? So we started talking to other groups who use news in the company, and it turned out there were 3 or 4 different products that all consumed news from these sources, but they all did it differently. Like we were doing ours in Perl in a giant cache. Some other folks were doing it in real time. Like as ticks came in, they would just display them on a screen. But there were all these different formats and everything. And so my approach to that was, again, let's normalize that across the company. And I came up with a way to use something called News ML, which is an XML-based news doc type to describe, what news looks like. And we implemented that. We extended the doc type a little bit, but implemented it across the entire company. And now it wasn't that there were 3 or 4 applications that displayed news. It was that we had a news infrastructure, and anytime anybody needed to use news items in their project, they didn't have to invent that anymore. There was a standard way using XML to query and receive news on anything that you wanted related to the feeds that we're getting. So that was a case where we actually, again, we said, look, here's the money you're going to save going forward. Here's how much it's going to cost. And it was just really clear that that was the right approach. So as part of the wrap job for a single project, we ended up with not a lot of additional cost with an enterprise-wide infrastructure for delivering this data that anyone could tap into. It was a big win for them, I think. But that's always in my head. As I'm approaching these kinds of projects, I'm always looking for ways to leverage it. Like, how can I, it's not even like, how can I save the money? How can I make data more uniform, I guess, is what I'm looking for. Because most companies, as I said, it's just splintered everywhere. Some disadvantages of wrapping, for sure. If I'm wrapping something like this and adding new functionality to it, I'm digging a big hole and planting that sucker in the ground. It's not going anywhere for any foreseeable time. I've got a lot of sunk cost already, probably, which is why I'm doing the wrap. B, I'm extending it with new functionality that's important to the business. Clearly, like, what am I going to do, right? I'm not going to just scrap all of that in the future. And so I'm digging the hole just deeper and deeper and deeper. I've got a short-term solution that buys me some time, maybe, but over time it's going to cost me a lot more money, probably. And in that case, I would probably suggest a scrap instead of a wrap. Usually, if I see older machines, like older mainframes, older processes, and so on, I'm trying to get away from a wrap, except in the case where I can do a 2-step process where we go in and do a wrap first. It's like, all right, look, you want to see real-time quotes. That's something we don't have right now. So, but I can get that data from the mainframe. Maybe I said can't display it right now. So I'll do a wrap job, just put a thin layer on top of the mainframe to generate that data and get it into a format that I can display, with the understanding that, in 3 quarters or so, maybe a year down the road, I'm going to move on from that. Like, I'm going to do a scrap in the end, but the scrap's going to take a long time. Scraps always take a long time because of especially all the work you have to do up front and all the testing. It's going to take me a year to do this project, but I want to deliver this functionality right now. And so I can spend a quarter wrapping something, getting something running, and then all this time underneath, I'm doing the scrap job. So that at the end of the year, I keep the new functionality, but now I get rid of the old system. And now that new functionality is part of the new system that I developed as part of the scrap job. So usually when I'm doing a wrap like that on an older system, I'm just trying to buy time, because I don't want this to happen. Sometimes it's like all we got. The CIO is in love with mainframes. That old HP mainframe is just going to sit there for a long, long time. Maybe it's, one of those things where it's just Kenny who knows how the thing works, and all I've got is the interfaces. I don't know what the internals look like. What am I going to do, right? And I'm also constrained by what the old system can do, but that's part of the decision to get to the scrap or the wrap. All right, let's talk data for a little bit. Yeah, a little bit. Somebody asked about data earlier. So data is usually the worst part of all of this. Like doing functionality stuff, I'm just building systems. We're just writing code and designing stuff. That's pretty simple. Data, though, again, data is the blood of any company, and I need not to spill any blood. Like I don't want any data loss. The data though from before has to look exactly like the data does now. And the problem I have is I'm probably moving to a new system, especially if I'm doing a scrap. These are usually going to be migrations to a new platform. So it is going to look like a scrap job. I've got to duplicate everything. And it's not just the data. There's usually procedures, stored procedures in there, triggers, constraints, keys. A lot of stuff goes into a database besides the data. And what if I'm moving to a new platform? I'm actually stuck in this right now. I've got a massive data migration project on my plate, and I've been avoiding it for 3 years now because it's going to be so painful. I probably have mentioned KidPub, that site that I built back in '95. It's one of the first 10,000 websites ever, still running. But it's gone through 2 rewrites. One rewrite. The original version was in Perl using CGI as the interface. This is like almost pre-web. Well, the web was just brand new in '95. Actually, seriously brand new in '95. It was released in like '94. So brand new code, a really awkward way of doing something. And it started out with just flat files as data. And then about 4 or 5 years later, I rewrote the entire thing in PHP. Well, that's where it sits now since 2000. This is 2021. So it's been sitting in PHP for 20 years. I haven't touched that code for probably 15 years. I need to move it. Like I need to move that to a new platform. I want to move it to the MeanStack or MERN, but the data are killing me. I want to go from a relational database to a non-relational database. It's in MySQL right now, and I want to move to Mongo. Those MySQL tables are really complex at this point. Like tons of triggers, tons of constraints on keys, like just really deep queries. A lot of stuff happening in the database on that site. Non-relational databases don't have a lot of that functionality. And so I've got to make a decision. And clearly I can't make the decision because it's literally been almost 3 years since I started working on this. I got to make the decision of what am I doing with 20 years of data? I've got stories going back to it's a story site, kids story site. I've got stories going back to 95. I got to keep them. I want to migrate them, but what's it going to look like on the new system? So data is always just such a heartache. It's so hard to do. There are tools that we can use. They're not perfect for sure. And the approaches are the same, right? We can wrap a database and translate stuff on the fly, modify it, scrap it. I'm looking at a scrap job. Actually, what I'm looking at is a scrap preceded by a wrap. So my idea is, why don't I build a layer in between the old database and a new database in Mongo? And then as the site works, so it's going to go through this interface, I'll make a query into the database to get a page of information. I'll display the page, but at the same time, send it out through the new interface to modify that stuff and store it in Mongo. So I can just test things like, test my ideas of what the data should look like at the end. And then once the wrap is complete, like, oh yeah, that wrap layer looks really good. Now the wrap layer becomes my primary interface, and I'm maybe just using the MySQL stuff as a backup. So I might wrap that in the process of doing a scrap. That would be that. I mean, scrapping is hard, right? Because data is the lifeblood of the company. I don't want anything to happen to it, and probably that's probably what I'm spending the most money on in terms of licenses and maintenance and so on, are my databases. So the big tool we're going to use is an ETL kind of tool. ETL comes from extract, transform, and load. And it's just a utility. So ETL tools like IBM DataStage, for example, DataStage is a great tool. It's wicked expensive now. Oh yeah, 150K per server. And that was probably 3 or 4 years ago. I wrote this slide. I remember we were on a job at Pioneer, and we were using DataStage. It was a little company, the tiny little company out in Waltham, out on 128. You know, it's run by 3 or 4 guys. You know, the typical, you know, coming out of college, writing this tool and getting a little seed money and so on. And they were really nice guys. They used to hang out in the office with us because they had nothing else to do. We were paying a fair amount of money for licensing, but they come in, you know, they'd be in t-shirts and shorts and so on, just hanging out, and we, you know, shooting the shit. And then one day we came in, and one of the guys was sitting in my office wearing a 3-piece suit, you know, like a Brooks Brothers suit. And I'm like, dude, like, what happened? Where are you going? You're interviewing? And he laughed and he goes, no, didn't you hear? IBM just bought us. They bought us for a lot of money. And those guys, I think most of them retired. But yeah, so IBM took it over. It was a great product. DataStage is a really great product. But what it does is it allows you to specify rules for data transformation. So the extract piece is, I'm going to pull data out of the old database. I'm going to transform it in some way, and then I'm going to load it into the new database. That's the ETL job. So ETL is, I mean, they're free things you can use for this too. None of them are going to work as well as the commercial products typically, unless you've got a really simple database, I guess. Yeah, so like the work process on this is you document what you've got. And that might be dumping entity relationship diagrams, ERDs from the database. If you understand what you've got in the old system, you start to lay that out in the new system. And I usually used an iterative approach to this. So I start with a few tables and write the transform jobs for the new tables. Here's the old table in the existing system, write a job that changes in some way, stores it in the new system, and then tests that to make sure that's correct. And then add a couple more tables, like just, you know, sort of aggregate it until I'm finished. That might take a couple of months to do that. So the E and T part, we're constantly just, that's the daily work. Working on the transforms, loading stuff or extracting stuff from the old database and testing it and make sure it looks right. And then at the end, let's say it takes a quarter to do this. At the end of the quarter, it's like now everything's been tested. We have all of the translation layers we need. Everything looks cool. And, you know, it's stuff like, oh, you know, a name is 25 characters in the old system. We're going to make it 30 characters in the new system, that sort of thing. And add a trigger to it. So you do all of that testing. And then at the very end, you do the entire process, ETL. So to this point, you've just been testing small pieces of it. Now you do the full load, extract, do the transform, do the new load. That's probably only take 20 minutes to do, or half an hour or something. But normally, you know, it's one of those jobs where you'd come in on a Friday, you know, like other deployments, come in on Friday with your sleeping bag. You're going to do it over the weekend, light it up, test it on Sunday, and then Monday, switch over to the new systems with your fingers crossed. It's a tough job, man. ETL is really, really tedious. I'm not that detail oriented. And so I get really crazy on jobs like this because I'm the big picture guy. And this is way down in the weeds. Like, you know, this thing is 4 bits wide and it should be 5 bits wide. And how are we going to manage that sort of thing? So ETL is a big job. Usually that's a specialist sort of thing. Maybe you'll work with a team that's coming in from a third-party vendor to do ETL for you. Normally, there's not somebody on staff who is expert in this. So I can adjust schema. I just mentioned adjusting schemas. I mean, you can do yourself. Like I've written ETL stuff in Perl, just really small tables with not a lot of triggers or procedures or anything. Just, you know, read it, load it, read it, load it. A couple lines of Perl and you're done. But whichever you use, you know, you need tons and tons of testing on all of these things. That's kind of an ongoing theme in 411 is testing is just so critical. And unfortunately, we don't even have a testing course here at BU. Like we should have a formal testing methodologies course. Maybe I'll mention that. We're talking curriculum next week. Be a good course to have. I would never teach that because it's way too tedious. It would make me nuts. Like I don't like that level of detail. I like to wave my hands. Which is interesting because teaching 210 now, like I'm way down on the weeds in 210. Like I am twiddling bits down in 210. I'm actually enjoying it. So maybe it doesn't make me crazy anymore. One last bit on migrations, and this always bites you too. And I've tweaked this a couple of times. I don't recall if this is still a circle or not. But like again, I'm stuck. It's KidPub. I'm stuck in KidPub, my website, with dependencies. I need to do upgrades on it. Like I'm running on a really, really, really old version of Drupal. Drupal is a PHP framework for content management. I'm on like version 5. What is the current version these days? Drupal's, there's a really cool company here in town that does Drupal consulting, if you're interested in that sort of thing. Let's see, resources, build solutions, try it. Just want to see what the current version is. Demo Drupal 8. Let's say it is 8 still. Cool. So I'm on 5. I'm 3 major versions back. I've got to upgrade my PHP version from 4 to 5. But version 5 doesn't support the database I'm running because it doesn't have the triggers I need. But a slightly older version of the database does have the triggers I need. They've kind of moved on in the new version of MySQL, but I've got these old style version 4 triggers. I can still use them in 5.5, so I might use that. But that requires the OpenSSL 10.2 package to connect to the database. And that requires libc version 9.7a. And I can't use 9.7a with PHP 5. And so I'm like on this circular, like horrible, like dependency hell, right? And to be honest, when I look at this, and I look at this every semester, I have for 3 or 4 years now, because this is my project. Every time I look at this, I think, Perry, just scrap it. Just start over. Keep the old data on the side. Figure out a way to make it read only so people can still see it. But just say done and move forward and stop trying to update everything. Maybe I'll get to that point. What are we doing, Yuval? Professor Gabordi working on a course involving formal verification and oh, nice. We're starting to get some chops in software engineering, eh? Very nice. Actually, we just hired a second professor to teach in the software engineering space. So maybe we're going to build a software engineering institute here at BU. People come here instead of CMU. Oh shoot, there's a whole bunch of shit down here. So like, and there's upstream dependencies, downstream dependencies. They're always going to creep up. We try to identify these early as part of the planning process, but honestly, there's always something. It's like these. I don't know if you watch these home improvement shows on TV at all. My wife is addicted to these things, and it's always they're tearing down something or rebuilding a kitchen or whatever. It's a formula kind of show. So 20 minutes into the 30-minute show, you're guaranteed that somebody's going to put a hammer into a wall, and they're going to say, oh, and then cut to commercial. It's like the oh shoot, we didn't realize like there was, I don't know, cooling water for a nuclear reactor in that wall. We can't take down the wall apparently, or there's electrical everywhere, or it's all post and tube, and fabric covered wire. Like it's always something, right, that you didn't expect. It's true of every project. It's certainly true of migrations. There's always some little thing that's going to come and bite you. But you know what? We plan for that. We know it's going to happen in every project. And so we put contingency time in those projects to deal with things that we don't know is going to happen. I guess that means we know it's going to happen. Doesn't compute. All right. And then JavaScript. I'm going to skip that bit. Last thing I'll say, because we're running out of time. That's just, this next few slides are just about JavaScript and dependencies and dangers you can get into. I just put them in there because I was thinking about them one day. So backwards compatibility is important too. It's those upstream processes that are feeding you stuff, but it's the downstream process that depends on what you're producing. I might have to put a layer in to mimic an older system. If I'm doing, especially if I'm doing a scrap, the downstream systems might expect that older system to be in place. I might have to transform data coming out of the new system so it matches what the old systems are expecting downstream. So there might be an additional layer involved in just sort of making that interface happen. I mean, it's not a big deal, but it's something we have to think about. I'd use like a facade or something for that, or an adapter. All right, 12, 13, and I'm out of slides. Oh, Andrew, I got a couple minutes. I'll talk about these. Let's see. When will older quizzes and so on be graded? There might only be one quiz outstanding. I'll make sure that those are graded soon. The midterms graded. so the midterms graded. By the way, the mean on the midterm I think was like 98.9. So you guys did fine on the midterm apparently. I thought the team assignments only had to be submitted by one team member. That is correct. Only one team member for the team assignments needs to submit it. And they're all going into your repo anyway. So once we have a link to your repo, we can just look in there for stuff. How am I doing? I'm doing just fine. I'm happy as a clam. Happy for the semester coming to a close. And happy to have a vaccine appointment. All right, guys, that is all I have on migration. I owe you at least one quiz. I'll put together a quiz for you over the next few days. And Andrew, I'll not to blow you off, I'll go and look and make sure that stuff is getting graded for you. It's always a challenge grading stuff. And you know, to be honest, between you and me, guys, like 210 is just sucking my soul out right now. I'm spending 99% of my time on 210, and unfortunately 411 is like, I'm not paying a lot of attention to it, to be honest. But I'll make sure that everything's getting done. All right, that is it. I will see all y'all next week. Go enjoy April Fool's Day. You're welcome, Manish. Have fun. Have a good weekend. Don't work on the weekend.
Peace, Professor. Have a good one.
You too, man.